This is Jeff Ebel with Bowling Train Services. Today we're going to go through owner's training for a TR200 drive. This is Y1, which is located on P2 parking garage. I'll start briefly. Here's the main disconnect for the drive. So this is your main power coming in. This is your drive, off, bypass, and test switch. In drive mode, the display up here will be lit up. That basically tells you have power, and this display will tell you what the drive is doing, how many amps it's drawing, what it's running at. If you turn this off, the screen will go blank, but you still have power coming into the drive bypass cabinet. Bypass, I'll show you internally where the contactors are. It will bypass the drive and go directly to the motor or the load. Test is essentially just for testing. Will not be used normal operation. Open this. You can either turn the disconnect to off, or there's a button right here on the side that you can push in and depress, and this will come off. Just be aware that there's 480 volts there. Briefly, I guess we'll start from the bottom. This is a third-party control measuring amp draw to make a switch, just basically a proof of operation. So the control will tell the drive to run. This will prove that it is in fact running. So your line comes in the bottom of the disconnect, goes out to various places. This is your M3 contactor. This is your M2 contactor directly above it, and your M1 contactor. Behind here on the side is your bypass power card, your main power to the bypass. Top here you can see there's 3 fuses. That's your fuses for the main power to the drive. That is your drive protection. L1, L2, and L3 come in the bottom of the drive. Output of the drive is UVW directly behind it. This is your bypass control card. These 2 wires here are your start command coming from your rib relay on the side here. When the light is on, it means there's a call for the drive. If it's on and there's no drive running, then there's an issue. This jumper would be if you had an external safety of any kind. You're not using it here, but just for your own knowledge, this would be where you would tie smoke or something of that nature, free stat, maybe on an air handler. This is where that would go, 5, 6. 1 and 2 would be a damper control or damper end switch if you were using it on an air handler or something of that nature, a pump making a flow switch. If you have power coming into the drive and you have power through the fuses, meaning these 3 fuses here are good, there are 3 fuses located on this bypass control power card. They are 20 amp fuses rated for 600 volt. They're not easy to get to. I would suggest turning the power off and pulling things out. Some of this stuff you have to pull out in order to access. Your auxiliaries are on the front of these. This is your overload. It's set for, looks like about 12. Based on the parameters here, it's a 12 amp motor, which is what you want that at. You want to protect the drive. That obviously is the most expensive portion of this device, including the motor. You really won't get into the controls on the drive. There's no reference for this particular drive. The low limit is 60 hertz, the high limit is 60 hertz. So basically if you have a call for this fan to come on, it's gonna run all out, all the time at 60 hertz. So it's essentially performing soft start for this motor. So it will take 60 seconds to ramp up on a call for the fan to come on and 60 seconds for it to ramp down on a call. The biggest thing to do, say you have a problem with your drive and you're not sure what's going on, maybe you don't have time to deal with it, or you think it's a drive issue and you just want to throw it in bypass. Switch it to off. Wait for the screen to go blank, then flip to bypass. If you flip it from drive to bypass immediately, there is a stored capacity in this drive. So you have the potential to blow a fuse or burn up the drive. Anytime this motor is running and you want it to stop, you should hit off rather than flipping the switch. It's always, you don't want a motor stopping or drive stopping when it's attempting to run. As far as troubleshooting, they can really get pretty complicated. The thing I suggest, and typically the first thing I would do if coming onto this job and you thought you had a drive issue, would be to take, these plugs come out. You can pull the plug with the wire directly out of the bottom of the drive. Would be to pull the plug with a UVW out of the drive. put the drive in hand and run it up to 60 hertz. If you're running at 60 hertz and you have voltage coming out of the terminals that were on UVW, then the drive is doing its job. It's either wiring, motor. Those are the most common problems with these. There's a cooling fan on top. Most people don't do it, but they should be blown out with dry nitrogen once a year. Just be careful how much pressure you use. You don't need much. If you're blowing up through the bottom here and you have that fan spinning, it shouldn't be spinning very, very rapidly, just a slow spin. That means you're getting enough airflow through there. But this can come off. It just snaps on. You can pull it off so you can actually get the dirt out of there. Obviously, it's not going to do you much good if you're blowing air through here and it's hitting the underside of this. This is exhaust fan on the P2 level, which is associated with Y1 drive. Powers this fan. It's a 10 horsepower motor. It's an exhaust fan. The air is pulled in through the garage. There's a set of dampers there. 2 greasable bearings on the shaft need to be done per manufacturer specs. Also determine the type of grease that needs to be used in this particular application, also be in the IOM. If you locate it on this box here, tells you the power for the drive which feeds the motor is an LP-2. It's a 30 amp breaker, 3-phase. It's number 8, 10, and 12. There are no grease fittings on the motor. It's a sealed motor. Rotation looking this direction is counterclockwise. It's 2 belts. There's spare belts here. Anytime you replace one of these belts, if one belt fails, you should replace both with a matched set. In other words, there are small differences. If you get matched belts, they're guaranteed to be exact. That is important, or you'll be changing belts much more often than you want to. You should check belt tension at least once a year and grease at least once a year. But like I said, refer to the manufacturer specs for grease, frequency, and type. Based on the location, being in a garage, you're probably going to grease a little more frequently than, say, an air handler because of dust and dirt. It's going to get a whole lot more wear than like an air handler. This is the exhaust damper for a P2 fan, parking garage level 2. Directly above is the barometric dampers for P1 parking level, which in turn goes up to the exterior to discharge air. This is the barometric dampers associated with exhaust fan on P2. They're the same as the exhaust fan on P1. Everything's identical from P2 to P1. Drive, motor, dampers. These are just barometric, so there's no controls. The force of the fan discharge will blow out. These dampers will open like so and discharge out to wherever they're exterior of the building. I would recommend that these get some kind of lubricant. There's rivet joints on every louver, especially if they're not worked and not used a lot, they will tend to bind up. So lubrication once a year maybe would be a good idea. But other than that, there's no real maintenance involved on these.